When you look up at the night sky, you see stars, planets, and faint smudges of distant galaxies. But hidden among those pinpricks of light are some of the most extreme, powerful, and mysterious objects the universe has ever created. They are so bright, they can be seen across 13 billion light years, so energetic, they outshine thousands of galaxies combined, and so strange that for decades scientists had no idea what they were. Today, we call them quasars, the cosmic lighthouses that burn brighter than anything else, all while feeding on the matter that surrounds them. This is the story of quasars, the devouring giants that illuminate the darkest corners of space and time. Let us start in the early 1960s, a time when astronomers were mapping the sky with radio telescopes and uncovering signals that made no sense. They found dozens of bright radio sources that looked like faint, ordinary stars when viewed through optical telescopes. No one could explain why these stars were blasting out huge amounts of radio waves, a trait no normal star had ever shown. One object, named 3C273, became the center of a scientific revolution. In 1963, Dutch-American astronomer Maarten Schmidt made a discovery that changed astrophysics forever. He studied the light spectrum of 3C273 and found something shocking. The spectral lines were shifted far toward the red end of the spectrum, an effect called cosmological redshift. This redshift was not from the star moving, but from the expansion of the universe, stretching its light as it traveled across billions of light years. Schmidt calculated that 3C273 was not a star in our galaxy at all. It was an object 2.5 billion light years away, far beyond the reaches of any star we could observe. For something that distant to appear, even faintly bright to our telescopes, it had to be shining with the intensity of trillions of stars. This was not a star, it was something entirely new. A year later, Chinese-American astrophysicist Hong Yi-Chu named these objects quasars, short for quasi-stellar radio sources, because they looked like stars, but acted nothing like them. For years, quasars remained the biggest puzzle in astronomy. How could an object barely larger than our solar system produce more energy than an entire galaxy holding hundreds of billions of stars? The answer would lead us to the darkest objects in the universe, supermassive black holes. Today, we know every quasar is powered by a supermassive black hole sitting at the heart of a distant galaxy. These black holes are not small. Their masses range from millions to tens of billions of times the mass of our Sun. A black hole itself is invisible. It emits no light, no radiation, nothing that we can directly detect. But the chaos happening around the black hole is anything but dark. Gravity pulls in every bit of nearby matter, clouds of gas, wisps of dust, entire stars torn apart by tidal forces. This material does not fall straight into the black hole. Instead, it spirals inward, forming a flat, spinning structure called an accretion disk. Imagine a cosmic tornado of matter, spinning at speeds close to the speed of light, compressed into a tiny volume, only a few light days to a few light years across. The friction and gravitational pressure inside this disk heat the matter to temperatures of millions of degrees Celsius. This extreme heat does not just glow, it erupts with radiation across the entire electromagnetic spectrum, from radio waves and infrared light to visible light, ultraviolet rays, X-rays, and even gamma rays. This is the light of the quasar, a beacon so intense it drowns out the light of every star in its host galaxy. To put this in perspective, a single quasar can shine 100 to 1,000 times brighter than the entire Milky Way galaxy, home to 200 to 400 billion stars. Some quasars release energy equal to 100 trillion suns every single second. The energy conversion here is far more efficient than the nuclear fusion that powers stars. While fusion converts less than 1% of mass into energy, the accretion process around a black hole can turn up to 40% of infalling mass into pure energy. This makes quasars the most efficient energy engines in the known universe. But the drama does not end with the accretion disk. About 10% of quasars produce something even more spectacular, twin jets of high-energy particles that blast outward from the black hole's poles at nearly the speed of light. These jets can stretch for hundreds of thousands, even millions of light years, into intergalactic space, carving paths through gas and triggering bursts of star formation in nearby clouds. When these jets collide with intergalactic matter, they create huge radio lobes that glow brightly in radio telescope images. These jets are not just cosmic fireworks. They shape the fate of entire galaxies. The intense radiation and particle streams push gas away from the galactic center, regulating star formation and linking the growth of the supermassive black hole to the growth of its host galaxy. This connection, called co-evolution, is one of the most important discoveries in modern galactic astronomy. For a long time, astronomers thought black holes and galaxies evolved separately. Now we know they grow together. The more matter a black hole devours to power a quasar, the more it shapes the stars, gas, and structure of the galaxy around it. When the black hole runs out of fuel, when there is no more gas or stars left to pull in, the quasar fades, and the galaxy becomes a normal, quiet system, like our Milky Way. Most large galaxies, including our own, were once quasars in their youth. Quasars are also time machines. Because they are so bright, we can see them at extreme distances, which means we see them as they existed billions of years ago. The farthest quasars we have found date back to just 600 to 900 million years after the Big Bang, an era when the universe was still in its infancy. At this time, the first galaxies were just forming, and the universe was emerging from the cosmic dark ages, a period before stars and galaxies existed. Quasars lit up this young universe, and their light carries clues about how the first black holes formed, how the first galaxies grew, and how the universe transitioned from a hot, dense soup of particles to the structured cosmos we see today. They act as cosmic lighthouses, their light passing through intergalactic gas clouds on its way to Earth. By studying how that light is absorbed and changed, astronomers can map the distribution of gas, dark matter, and heavy elements in the early universe. Quasars have helped us measure the expansion rate of the universe, test Einstein's general relativity, and understand the nature of dark energy, the mysterious force pushing the universe apart at an accelerating rate. NASA's space telescopes have revolutionized our study of quasars. The Hubble Space Telescope has captured high-resolution images of quasar-host galaxies, revealing merging systems, tidal tails, and chaotic environments where black holes feast on fresh gas. In 2024, Hubble took the closest ever look at 3C273, unveiling structures within 16,000 light-years of the central black hole, including clumps of matter falling toward the accretion disk and filamentary shapes shaped by powerful quasar winds. The James Webb Space Telescope, with its infrared vision, peers through dust clouds to see the faintest, most distant quasars ever detected, unlocking secrets about the first supermassive black holes in the universe. The Chandra X-ray Observatory detects the super-hot X-rays from accretion disks, measuring the mass spin and feeding rate of black holes powering quasars. Together, these missions turn distant points of light into detailed stories of cosmic growth and destruction. What makes quasars so spiritually and scientifically meaningful is that they represent the dual nature of the universe, creation and destruction. A quasar devours matter, tearing apart stars and gas to feed its central black hole, a process that seems violent and destructive. Yet, that same process creates the brightest light in the cosmos, illuminates the early universe, regulates galaxy growth, and seeds space with heavy elements forged in the hearts of stars. Quasars remind us that destruction in the universe is not an end, but a beginning. They are proof that even the darkest objects in space can create the most brilliant light, and that the most extreme events in the cosmos are the ones that write the rules for everything else. As we continue to explore the cosmos, quasars will remain among our most valuable guides. They challenge our understanding of physics, gravity, and energy. They show us how galaxies are born, live, and change over billions of years. They let us look back in time to the universe as first steps, connecting us to the moments when everything we see today was just starting to form. Every time we detect a quasar, we are not just seeing a distant object, we are witnessing an engine of cosmic evolution, a devourer of matter, and a beacon that has shone across most of the universe history. The universe is full of wonders, but few are as grand as powerful, and as enlightening as quasars, the brightest lighthouses that turn darkness into light and chaos into order. Please like, comment, share, and subscribe to the channel.